Java Platform Standard Edition. Java Platform Standard Edition Java SE is a computing platform for development and deployment of portable code for desktop and server environments. Java SE was formerly known as Java 2 Platform Standard Edition J2 SE. The platform uses Java programming language and is part of the Java software platform family. Java SE defines a range of general-purpose APIs such as Java API for the Java class library and also includes the Java Language Specification and the Java Virtual Machine Specification. OpenJDK is the official reference implementation since version 7. Nomenclature, standards, and specifications. The platform was known as Java 2 Platform Standard Edition, or J2 SE from version 1.2, until the name was changed to Java Platform. The SE is used to distinguish the base platform from the Enterprise Edition Java EE and Micro Edition Java ME platforms. The 2 was originally intended to emphasize the major changes introduced in version 1.2, but was removed in version 1.6. The naming convention has been changed several times over the Java version history. Starting with J2 SE 1.4 Merlin, Java SE has been developed under the Java community process, which produces descriptions of proposed and final specifications for the Java platform called Java Specification Requests JSR. JSR 59 was the umbrella specification for J2 SE 1.4, and JSR 186 specified J2 SE 5.0 Tiger. Java SE 6 Mustang was released under JSR 270. Java Platform Enterprise Edition Java EE is a related specification that includes all the classes in Java SE, plus a number that are more useful to programs that run on servers as opposed to workstations. Java Platform Micro Edition Java ME is a related specification intended to provide a certified collection of Java API for the development of software for small, resource-constrained devices such as cell phones, PDA, and set-top boxes. The Java Runtime Environment JRE and Java Development Kit JDK are the actual files downloaded and installed on a computer to run or develop Java programs, respectively. General-purpose packages. Java Lang. The Java package Java Lang contains fundamental classes and interfaces closely tied to the language and runtime system. This includes the root classes that form the class hierarchy, types tied to the language definition, basic exceptions, math functions, threading, security functions, as well as some information on the underlying native system. This package contains 22 of 32 arrow classes provided in JDK 6. The main classes and interfaces in Java Lang are object, the class that is the root of every class hierarchy. Enum, the base class for enumeration classes as of J2 SE 5.0. Class, the class that is the root of the Java reflection system. Throwable, the class that is the base class of the exception class hierarchy. Error exception and runtime exception, the base classes for each exception type. Thread, the class that allows operations on threads. String, the class for strings and string literals. String buffer and string builder classes for performing string manipulation. String builder as of J2 SE 5.0. Comparable, the interface that allows generic comparison and ordering of objects as of J2 SE 1.2. Iterable, the interface that allows generic iteration using the enhanced for loop as of J2 SE 5.0. Class loader, process, runtime, security manager, and system classes that provide system operations that manage the dynamic loading of classes, creation of external processes, host environment inquiries such as the time of day, and enforcement of security policies. Math and strict math classes that provide basic math functions such as sine, cosine, and square root. Strict math as of J2 SE 1. The primitive wrapper classes that encapsulate primitive types as objects. The basic exception classes, thrown for language level and other common exceptions. Classes in Java Lang are automatically imported into every source file. Java Lang Ref. The Java Lang.ref package provides more flexible types of references than are otherwise available, permitting limited interaction between the application and the Java Virtual Machine JVM garbage collector. It is an important package, central enough to the language for the language designers to give it a name that starts with Java Lang, but it is somewhat special purpose and not used by a lot of developers. This package was added in J2SE 1.2. Java has an expressive system of references and allows for special behavior for garbage collection. A normal reference in Java is known as a strong reference. The Java Lang.ref package defines three other types of references: soft, weak, and phantom references. Each type of reference is designed for a specific use. A soft reference can be used to implement a cache, an object that is not reachable by a strong reference that is not strongly reachable, but is referenced by a soft reference is called softly reachable. A softly reachable object may be garbage collected at the discretion of the garbage collector. This generally means that softly reachable objects are only garbage collected when free memory is low, but again, this is at the garbage collector's discretion. Semantically, a soft reference means keep this object when nothing else references it, unless the memory is needed. A weak reference is used to implement weak maps. An object that is not strongly or softly reachable, but is referenced by a weak reference is called weakly reachable. A weakly reachable object is garbage collected in the next collection cycle. This behavior is used in the class java.util. Weak hash map. A weak map allows the programmer to put key/value pairs in the map and not worry about the objects taking up memory when the key is no longer reachable anywhere else. Another possible application of weak references is the string intern pool. Semantically, a weak reference means get rid of this object when nothing else references it at the next garbage collection. A phantom reference is used to reference objects that have been marked for garbage collection and have been finalized but have not yet been reclaimed. An object that is not strongly, softly, or weakly reachable, but is referenced by a phantom reference is called phantom reachable. This allows for more flexible cleanup than is possible with the finalization mechanism alone. Semantically, a phantom reference means this object is no longer needed and has been finalized in preparation for being collected. Each of these reference types extends the reference class, which provides the get method to return a strong reference to the referent object, or null if the reference has been cleared or if the reference type is phantom, and the clear method to clear the reference. The Java Lang.ref also defines the class reference queue, which can be used in each of the applications discussed above to keep track of objects that have changed reference type. When a reference is created, it is optionally registered with a reference queue. The application polls the reference queue to get references that have changed reachability state. Java Lang.reflect. Reflection is a constituent of the Java API that lets Java code examine and reflect on Java components at runtime and use the reflected members. Classes in the Java Lang.reflect package along with Java Lang. Class in Java Lang. Package accommodate applications such as debuggers, interpreters, object inspectors, class browsers, and services such as object serialization and JavaBeans that need access to either the public members of a target object based on its runtime class or the members declared by a given class. This package was added in JDK 1.1. Reflection is used to instantiate classes and invoke methods using their names, a concept that allows for dynamic programming. Classes, interfaces, methods, fields, and constructors can all be discovered and used at runtime. Reflection is supported by metadata that the JVM has about the program. Techniques. There are basic techniques involved in reflection. Discovery. This involves taking an object or class and discovering the members, superclasses, implemented interfaces, and then possibly using the discovered elements. Use by name involves starting with the symbolic name of an element and using the named element. Discovery. Discovery typically starts with an object and calling the object. The class object has several methods for discovering the contents of the class. For example, getMethods returns an array of method objects representing all the public methods of the class or interface. getConstructors returns an array of constructor objects representing all the public constructors of the class. getFields returns an array of field objects representing all the public fields of the class or interface. getClasses returns an array of class objects representing all the public classes and interfaces that are members, e.g. inner classes of the class or interface. getSuperClass returns the class object representing the superclass of the class or interface. Null is returned for interfaces. getInterfaces returns an array of class objects representing all the interfaces that are implemented by the class or interface. Use by name. Arrays and proxies. The Java.lang.reflect package also provides an array class that contains static methods for creating and manipulating array objects, and since J2SE 1.3, a proxy class that supports dynamic creation of proxy classes that implement specified interfaces. The implementation of a proxy class is provided by a supplied object that implements the invocation handler interface. The invocation handlers invoke object method is called for each method invoked on the proxy object. The first parameter is the proxy object. The second parameter is the method object representing the method from the interface implemented by the proxy, and the third parameter is the array of parameters passed to the interface method. The invoke method returns an object result that contains the result returned to the code that called the proxy interface method. Java.io. The Java.io package contains classes that support input and output. The classes in the package are primarily stream-oriented. However, a class for random access files is also provided. The central classes in the package are input stream and output stream, which are abstract base classes for reading from and writing to byte streams, respectively. The related classes reader and writer are abstract base classes for reading from and writing to character streams, respectively. The package also has a few miscellaneous classes to support interactions with the host file system. Streams. Random access. The random access file class supports random access reading and writing of files. The class uses a file pointer that represents a byte offset within the file for the next read or write operation. The file pointer is moved implicitly by reading or writing, and explicitly by calling the seek-long or skip bytesInt methods. The current position of the file pointer is returned by the getFilePointer method. File system. The file class represents a file or directory path in a file system. File objects support the creation, deletion, and renaming of files and directories, and the manipulation of file attributes such as read-only and last modified timestamp. File objects that represent directories can be used to get a list of all the contained files and directories. The file descriptor class is a file descriptor that represents a source or sink destination of bytes. Typically, this is a file, but can also be a console or network socket. File descriptor objects are used to create file streams. They are obtained from file streams in Java, net sockets, and datagram sockets. Java.nio. In J2SE 1.4, the package Java.nio or non-blocking I/O was added to support memory mapped I/O, facilitating I/O operations closer to the underlying hardware with sometimes dramatically better performance. The Java.nio package provides support for a number of buffer types. The subpackage Java.nio charset provides support for different character encodings for character data. The subpackage Java.nio channels provides support for channels, which represent connections to entities that are capable of performing I/O operations, such as files and sockets. The Java.nio channels package also provides support for fine-grained locking of files. Java.math. The Java Math package supports multi-precision arithmetic, including modular arithmetic operations, and provides multi-precision prime number generators used for cryptographic key generation. The main classes of the package are: Big Decimal provides arbitrary precision signed decimal numbers. Big Decimal gives the user control over rounding behavior through rounding mode. Big Integer provides arbitrary precision integers. Operations on big integer do not overflow or lose precision. In addition to standard arithmetic operations, it provides modular arithmetic, GCD calculation, primality testing, prime number generation, bit manipulation, and other miscellaneous operations. Math context encapsulate the context settings that describe certain rules for numerical operators. Rounding mode and enumeration that provides 8 rounding behaviors. Java.net. The Java.net package provides special I/O routines for networks, allowing HTTP requests, as well as other common transactions. Java texts. The Java text package implements parsing routines for strings and supports various human-readable languages and locale-specific parsing. Java.util. Data structures that aggregate objects are the focus of the Java.util package. Included in the package is the Collections API, an organized data structure hierarchy influenced heavily by the design patterns considerations. Special purpose packages. Java.applet. Created to support Java.applet creation. The Java.applet package lets applications be downloaded over a network and run within a guarded sandbox. Security restrictions are easily imposed on the sandbox. A developer, for example, may apply a digital signature to an applet, thereby labeling it as safe. Doing so allows the user to grant the applet permission to perform restricted operations such as accessing the local hard drive. Digital certificates are issued by certificate authorities. Java.beans. Included in the Java.beans package are various classes for developing and manipulating beans, reusable components defined by the Java.beans architecture. The architecture provides mechanisms for manipulating properties of components and firing events when those properties change. The API in Java.beans are intended for use by a bean editing tool in which beans can be combined, customized, and manipulated. One type of bean editor is a GUI designer in an integrated development environment. Java.awt. The Java.awt, or Abstract Window Toolkit, provides access to a basic set of GUI widgets based on the underlying native platform's widget set, the core of the GUI event subsystem, and the interface between the native windowing system and the Java application. It also provides several basic layout managers, a data transfer package for use with the clipboard and drag and drop, the interface to input devices such as mice and keyboards, as well as access to the system tray on supporting systems. This package, along with javax.swing, contains the largest number of enums, 7 in all in JDK 6. Java.rmi. The Java.rmi package provides Java remote method invocation to support remote procedure calls between two Java applications running in different JVM. Java.security. Support for security, including the message digest algorithm, is included in the Java.security package. Java.sql. An implementation of the JDBC API used to access SQL databases is grouped into the Java.sql package. javax.rmi. The javax.rmi package provides the support for the remote communication between applications using the RMI over IAP protocol. This protocol combines RMI and Corba features. Java SE Core Technologies Corba/RMI IAP. Javax.swing. Swing is a collection of routines that build on Java.awt to provide a platform-independent widget toolkit. Javax Swing uses the 2D drawing routines to render the user interface components instead of relying on the underlying native operating system GUI support. This package contains the largest number of classes, 133 in all, in JDK 6. This package, along with java.awt, also contains the largest number of enums, 7 in all, in JDK 6. It supports pluggable looks and feels paths so that widgets in the GUI can imitate those from the underlying native system. Design patterns permeate the system, especially a modification of the model view controller pattern, which loosens the coupling between function and appearance. One inconsistency is that as of J2 SE 1.3, fonts are drawn by the underlying native system and not by Java, limiting text portability. Workarounds such as using bitmap fonts do exist. In general, layouts are used and keep elements within an aesthetically consistent GUI across platforms. javax.swing.text.html parsers. The javax.swing.text.html parser package provides the error-tolerant HTML parser javax.xml.bind.annotation. The javax.xml.bind.annotation package contains the largest number of annotation types, 30 in all, in JDK 6. It defines annotations for customizing Java program elements to XML schema mapping. OMG packages, org.omg, Corba. The org.omg Corba package provides the support for the remote communication between applications using the general inter-ORB protocol and supports other features of the Common Object Request Broker architecture. Same as RMI and RMI, this package is for calling remote methods of objects on other virtual machines, usually via network. This package contains the largest number of exception classes, 45 in all, in JDK 6. From all communication possibilities, Corba is portable between various languages. However, with this comes more complexity. These packages were deprecated in Java 9 and removed from Java 11. org.omg PortableInterceptor. The org.omg PortableInterceptor package contains the largest number of interfaces, 39 in all, in JDK 6. It provides a mechanism to register ORB hooks through which ORB services intercept the normal flow of execution of the ORB. Security. Several critical security vulnerabilities have been reported. Security alerts from Oracle announce critical security-related patches to Java SE.